Imagine that we lined up a bunch of gliders and told them all to fly at different airspeeds. The result would look something like this. The black glider flew the fastest, so it's furthest along, but it's also the lowest, in other words, it had the worst performance. The red glider flew the slowest, and it's the highest, but it hasn't gone very far. The green and blue gliders fall somewhere in between. Basically what we've done here is to get 4 data points that describe the sink rate of the glider as a function of the airspeed. If we were to plot this data on a graph, it would look like this. The red glider flew at an airspeed of 40 knots and was sinking at about 1.6 knots. Since the glide ratio is the airspeed divided by the sink rate, the red glider had a glide ratio of 40 divided by 1.6, or about 25:1. The green glider is sinking at about 2 knots while flying at 60 knots, for a glide ratio of 30:1, and the blue glider is flying at 80 knots and coming down at 3.7 knots for a glide ratio of 22. And the black glider, flying at 100 knots, had a sink rate of 7 knots for a glide ratio of 14. If we measured the sink rate for all airspeeds and plotted the results, we'd get a curve that looks like this. Of course, the far left of the curve drops off because if you fly too slow, the glider stalls. This graph is called a glider polar. From the polar, we can determine the sink rate of the glider at any airspeed.